All right, in this lecture, we're going to be talking about geoarchaeology, stratigraphy, and formation processes. Well, what is geoarchaeology? It is the field of study that applies the concepts and methods of the geosciences to archaeological research. And what that helps us to do is distinguish natural and cultural strata, helps us to create the sort of stratigraphic profiles that you heard me talk about during the excavation lecture, and then also gain an understanding of site formation processes. So what sort of effects have been in place on the site since it was occupied in the past. Now, as I said, this comes out of geology, and if you're not already aware with what geology is, it's the study of the Earth's physical structures and substances, its history, and the processes that act on it. So this tells us all kinds of important information, different rock types, which might be useful for lithic analysis. Petrology and mineralogy is actually something that I use in the research I do with pottery. There are sorts of weathering or erosional processes that we need to know about. Geomorphology is what that kind of falls underneath. You're seeing a beautiful image of structural geology in the background of this slide. This is the sort of forces that are at work that would have scrunched these rocks together to create this crazy zigzag pattern that you're seeing. Anyway, stratigraphy is the key principle then that we use in archaeology, but it's important to remember that we borrowed this from geology. The basic unit of stratigraphy is what's called a stratum, and that is a distinctive layer of rock, the plural of which would be strata, so that's what you're seeing in the images here. Stratigraphy, therefore, is the study of rock layers and the sequence of events that they represent. And so this is a geological map of a nice profile showing some faults and how that would have messed up or disrupted the natural layering of these rock deposits through time. When it comes to archaeology, there are some stratigraphic principles or laws that we need to keep in mind, and this is going to be really important for your activity in which you will be determining the order of layers in two different profiles. So the first is the law of superposition, and this applies to sedimentary deposits, or what we call layer cake stratigraphy, like you can see in the image on the left. And what it means is that the oldest layers are at the bottom, the youngest layers are at the top. Makes sense, right? In this case, each stratum is younger than the one beneath it, because in order for that to be put in place, the lower one had to already have been there, right? This is a nice image that shows you the progression of different layers being deposited on top of one another. However, at the end there, we get what's called a cross-cutting deposit. And in that case, a cross-cutting deposit is always younger than the deposit or deposits that it cuts through, because in order for it to cut through those horizontal layers already had to be in place. This is a nice stratigraphic profile. It shows us the modern ground surface all the way down into prehistoric time with some helpful modern and historic artifacts to show that we are going from the youngest at the uppermost point to the oldest and the deepest part of the profile. Any other Midwest transplants will be familiar with wintertime stratigraphic profiles, as I am. This is, a bit of a joke, but it also shows you can, interpret different deposits within the snowbanks even. Why is recording stratigraphy important? Well, ultimately it allows us to tie deposits across excavation units or perhaps across different sites. So in this example, we're seeing the same rock type and fossil type that is in this deposit across two different sites, two different localities. That allows us to then understand how the stratigraphy of two different areas is related to one another, because we can see that one relationship then allows us to understand, well, this nice yellow layer isn't even present in locality B, and things like that. Stratigraphy is often complicated. Structures from later phases of occupation can cut into or overlay previous features, and you're seeing some examples of that in the images here. Humans themselves also tend to intermix deposits. For the site where I work, we don't have a lot of materials from the later phases the earlier phases, and that's because the materials get incorporated into later construction activities. There's also natural or cultural processes that can create what we would call reverse stratigraphy. So even though this is the sequence of layers as they progress through time, perhaps some sort of huge erosion activity would come through here, and if it cut all this out, you would see, the orange layers coming downhill being deposited first, then the red on top of those, green, blue. Well, suddenly you have reverse stratigraphy, and you would need to look for more information in order to determine that. Along those lines, it's important to introduce what's called the POMPEII premise, and this means that in an ideal world, the archaeological record would reflect the past perfectly, and that was the case at least in the site of Pompeii, where this massive volcanic explosion came through and preserved people, animals, their food, everything in place. Most often, though, what we dig are not these sort of Pompeii events. In this case, the archaeological record does not equal past behavior. Instead, the archaeological record equals past behavior times what we call formation processes. So these are processes that transform the material remains of past behavior. They can modify different objects, move them around, increase or decrease the quantities of objects within different layers, so really complicating things for us. And there are two primary types of transformations, natural and cultural. And so natural would include any kind of freeze-thaw mechanisms that are happening in the soil, animals and plant roots messing things up. Cultural transformations obviously involve human intervention. Let's take a look at a few examples. So here we're seeing the destruction of a building. However, the forces behind that, the processes behind that are different when you consider that one was purposefully demolished, so a cultural transformation, and the other was destroyed by an earthquake, which is a natural transformation. The same can apply in faunal analysis. So the image on the right, we're seeing explicit cut marks, and experts are able to identify that based on the angle, the depth at which different marks were made, where they're located on the bone themselves, versus what you're seeing in the image on the right, which are rodent marks. So any kind of midden trash deposit, rodents love to go after that. They're gnawing away. Well, this is not processing of the bone. It's just naturally occurring transformation. I really like this image because it takes you through the whole life cycle of a stone axe. So it begins with acquiring the material itself. You actually manufacture it into this nice polished axe. It is used for its purpose of cutting down trees and other tasks. But let's say you lose it when you're out in the forest one day, and it enters into what is called the archaeological context then. So it enters into the ground, eventually gets buried over. Later, cultural and natural sorts of transformations occur. Maybe it becomes damaged while it's underground. All of that happens before an archaeologist actually recovers it. Formation processes occur in two particular contexts. The first being what's called the systemic context, and that is when objects are being used within a dynamic behavioral system. So they're in use right now. I'm using my computer to record myself to talk to you. It's in its systemic context. Now, if I were to throw this computer away and it entered into a landfill, then it's entering what could be considered an archaeological context. So this is after a structure is abandoned, objects are lost or discarded, they enter into the archaeological record. And so the images you see on the bottom is, what is a lived-in pueblo. One day, several decades from now, could end up looking like this. The rocks are exposed because the nice plaster coating on the outside has eroded away. And then you go even a few more decades further, and it's just a pile of rubble. So as I said, there's two contexts within which formation processes occur, and there are 4 different types of processes that happen. So within the systemic context, we have things like cultural deposition. So that is how the artifact itself actually enters into the archaeological record. So any kind of loss or discard purposeful caching of objects, or the ritual interment of those things, perhaps in a burial. Reclamation can occur when an older artifact is recovered and put to use by a later society. So perhaps you find a discarded point, resharpen it, use it for something else later on, or a potsherd from a broken vessel that you then use later on to scrape hides. Cultural disturbance, this is when human behavior disrupts the stratigraphy of the past occupation. So for example, constructing a pit house over some older hearth feature. And then lastly, reuse. This is when an artifact can be repurposed within its lifetime, that is, before entering the archaeological record, which is unlike reclamation. For this, an example would be sherds that are ground up and used as temper in new vessels. Within the archaeological context, then, we have geological deposition, and that is just the placement of, what are called alluvial, so by air, alluvial, colluvial, aeolian deposits. Aeolian is air deposited materials within a feature or a site. Your textbook talks about the gate cliff site as this sort of geological deposit. Erosion is what occurs when there's the removal of deposits due to wind or water. So for example, a river cutting through a site would take away some of the material and features. Soil formation, so if sediments have been in place for long enough, then you start to see the sort of chemical and mechanical alteration that can occur and can be recognized. And then lastly, there's turbation, and there's 4 different forms of turbation I think that your textbook talks about, or maybe it's even more than that. But this is the mixing of deposits by a variety of different types of agents. And there was a video in the excavation lecture that talked about one particular form of bioturbation, which was rodent burrows through their site. And if you go back and listen to that, you can see how they dealt with, dealing with that sort of bioturbation.